Looks like it's time to start. Welcome back, everyone. I'm just looking at my digital pen here. It looks like it's starting to break after so many years of using it. But for the announcements today, I don't have anything too major aside from what you see on the screen here. But any questions that folks would like to start us out with today? Okay. One thing I do want to mention is I have a really weird peripheral vision. Most people are kind of out here with their peripheral vision, maybe even further. For me, it's more like this. So I kind of swivel a lot when I ask for questions. And if I miss your hand, just wave it or something. I see movement sometimes more easily. But let's get back to the rest of these announcements. One thing I want to talk about today is just a little bit more about WebAssign. I have a list of things I want to make sure I mention today. When you get into WebAssign, like we mentioned before, your assignments are really just listed out here. I'm usually a little bit ahead. I try to put in some of these sections even before we're intending to cover them that day. And working ahead is just fine, but it can be more difficult if we just haven't discussed those topics. So some people, depending on your learning style, you might find it just more reasonable or relaxing to say start section 1.3 once you see the due date, meaning we intend to complete that section today. Once you go into a section, another thing we mentioned before is you're always welcome when you're working any of these problems to click on this button right here, ask your teacher. And what the heck, let's actually do it today, just see what happens. If you click on this, what's going to do is just give some kind of message that you can write, and it can be really, really informal. Don't worry too much about formatting or perfect English or anything like that. You could just say, hey, Mike, this problem seems odd. Can you help? Anything like that's going to be perfectly fine. The moment you hit send on that, it's going to send a message to my WebAssign. That's going to bounce to my email address. And then I go back into the WebAssign and I just respond to it. It shows me the problem you have. It shows me any attempts that you've tried and things like that. And so I try to tune my response to the things that you've been working on with that problem. After I respond, well, it might feel like I just ghosted you. I never got back. And one thing I've discovered about WebAssign is on a student per student basis, there is a really important little button up here. It's right up here by that little email notification settings. And I highly suggest everyone click on, let's see here, private message from the instructor, extension request replies. I mean, that would be a good one, I guess, but you might get some spam. I'd probably take that one off on second thought. And definitely ask your teacher replies. That way, once I reply, if you're working on that assignment right now, you probably want to see that reply sooner than later, and you'll get that notification. If you're not too worried about it, then I'd say it's not a big deal. Well, let's actually put this on the notes since it could be helpful for later. So first thing, click up here. Just take that as a screenshot. I'm going to drop this on the very bottom of the section 1.3 notes. So if you have to come back to it, here's the paper trail on how to get there. So first click here at the top. And then the next thing to do, I mean, kind of tedious that you have to do this, but I guess customization can be nice. This was my recommendations: extension request replies, private message from the instructor, ask your teacher replies. I don't think I'll use this a lot, but if I have cause to, you might as well get a notification for that as well. If these are turned off, you'll only know you have a notification if you're in WebAssign itself. You won't get the email. So these are my recommendations for those settings. Let's just say then click these recommended options, and you should be all set. That way it'll just be a little bit more streamlined when you're using WebAssign. Any questions about that so far? Okay, so back in WebAssign, I think I did have a couple. Let me go back to my script here, discuss the read at length. That's a good one to take a look at. So say you use the ask your teacher, things like that, but you still want to get more intuition on what's going on with the particular problem. Other thing you can click on, I think we showed this before, is just simply read it. And this is nice. What it does is it directs you to the spot in the textbook where that question is really coming from. It'll just take a bit to load. So there's that question, and this is the actual textbook. Looks like it turned to section 1.2 on us. So that's just a couple tricks for using WebAssign. There's a bunch more that I want to discuss, but for where we are now in week 1, I think those are the major things to be aware of. Yes, go ahead.
Back in WebAssign, when it says give an explanation, do you click on my notes to add the explanation?
You know, that's a weird, just a way that WebAssign works. When they say give your explanation, this and that option you selected is the explanation. It's just a really weirdly worded problem, I'd say. Me too, when I read that. Yeah, so these are all just multiple choice. It's more about recognizing which is the most correct response.
Because I added a note to you, but I'm like the explanation.
Yeah, it's really redundant in the way they said that.
All right. Thank you.
Yep, you bet. Other questions at the moment? Okay, and maybe one other thing to mention about these sections are sometimes really fast. This is 4 problems. They're all multiple choice. I do give multiple attempts. It's 4 attempts per problem for the entirety of WebAssign itself. That means you could go through this really fast, but if you spent less than half an hour, I'd say, completing this section 1.2, you may not be retaining as much. That's not for everyone, but for the typical student, I'd say spend about a half an hour on some of these quick sections in chapter 1, just to make sure you're really absorbing and reading. Why is one option correct and then another one incorrect? What was the difference? If you can spot that easily in your mind and you got it done real fast, then good on you. But I would definitely not rip right through it. You'd get the points, but then when it comes time to do a quiz problem based off of this or an exam setting, it'll all be much, much harder unless we actually spend the time studying here. Well, that was my quick blurb today. Maybe last thing I want to mention is if you want to switch sections or do anything else, there's other interesting links up here. Let me just move that down temporarily. This is the student view for me. So I don't know if anything is exactly the same for you. Let me know if there's some differences. Something I did find interesting was if you click down here under resources, this is our actual textbook. Our author last name is Peck. There's things like book resources. You may not have that one, but on a chapter by chapter basis, you have interesting lecture videos that you might want to take a look at. Some of these can be just a nice way to change how you're studying. If you've been reading and reading and reading, changing the mode up to something else, maybe writing or watching a video, gives your brain a break and you're still learning quite a lot that way. So if you can see those down there, give them a try. If they're missing, let me know. That might just be something I wasn't aware of. I might be able to find an alternate way of getting those out. And finally, last thing I promise, and then we'll go back to our Moodle website. Probably the better way to study for this class is take a look at the schedule, look at what's coming up next in WebAssign. If you say, for example, have the time before you even come to class, it'd be a really good idea to look at section 1.4 or section 1.5. Even if you don't read the book entirety in its high level, just scanning those contents will help out a lot. So before doing, say, section 1.5, before we came to class for that, it'd be a good idea to go to My eBooks. Here's our author's textbook once again, and just go to that section 1.5 and give it a read. Let's see, it's going to be in section 1, collecting data, chapter 1. There's lots of clicking here. It's not where I wanted to go, so click on the menu button another time, and then you can go right to 1.5 in that way. Well, any questions at all, folks, about navigating WebAssign, the textbook, or other things like those? Okay, well, let's now go back to the Moodle website. And what we're doing for today is going back to section 1.3 to complete it. And if we can, we'll see how far we get in section 1.4. We might end up somewhere in the middle, but we'll see where we end up. I mostly was intending to complete this, I think, on Thursday. Well, any last questions, folks, before we find where we left off in section 1.3? Okay, well, we're mainly done with that section. We're just going to the last illustrative definitions and some really quick examples. We left off on, not that, that was our settings for WebAssign here, but illustrating the so-called simple random sample. Random sampling is absolutely crucial in statistics since collecting data, calculating statistics like the sample mean, it's all worthless if your data is biased. Protection against bias in the data would be using some kind of randomization. And we mentioned before, in statistics, this is practically a gold standard. It may not be the easiest way to get your sample, but if the simple random sample works, the methods using your data are fast and powerful. So here we constructed a simple random sample involving those students. All we did was we made a sampling frame. We list out everyone according to numbers, gave some randomization here, and sorted to get the top 7. I won't ask you to do that to repeat it in that class. Really, this was more for just demonstration purposes. Did anyone have any questions about doing the simple random sample here? Okay, well, the last several concepts here are, let's suppose the situation is a little bit different. When we did this example, constructing our own simple random sample, we said the population ought to be all ISU students taking Math 1153P today. Let's say today is also today. It looks like about the same amount of people is here. But let's suppose we change the population. Suppose that we use a simple random sample constructed above. So we're going to use this still. And now assume the population of interest is all Math 1153 students at ISU. We touched on this a little bit before, but this would be massively biased. If we want to learn about all Math 1153 students, our randomization has to select from the pool of every Math 1153 student, not just our particular class that we're in here today. So if we did something like this, that would be our example of dealing with selection bias. Does that make sense to folks? Okay, so depending on what the actual population is, what you're trying to learn about, your sampling method might be great, like in this case, where the population was just the class, or it might be horrendous, like in this case. Here we can say, since we only sampled one class, we have selection bias. And so the data cannot be trusted. Well, any questions or comments so far, folks, about selection bias? Okay, there's many other kinds of biases, and this chapter 1.3 is a pretty long chapter. There's other things about, say, stratified sampling, systematic sampling, convenience sampling, and so on. But these are going to be the main things that we focus here on the notes here today. The simple random sample, and just a couple issues of biases and sampling. Well, let's take a look at a couple more, just for the sake of finishing off the notes. Selection bias is a problem if our sampling method is just not targeting the underlying population that we care about. Another bias is either you could call it measurement bias. That could be appropriate if, say, maybe your measurement equipment is wrong. Maybe you're trying to find the height of 5th graders at some school, and your tape measure is flawed. It's giving like a half a centimeter extra to everyone. In that case, now you're dealing with measurement bias, which could also be called response bias. Here, our setting is the population will be all Idaho residents. We're going to select a simple random sample. That lowercase n is just saying what the sample size will be. So it'll be 1,000 Idaho residents. And we're going to ask them the following question. So this is a survey. Surveys like these have been done, and they're also massively flawed. Sometimes you might see this on, say, a news channel, if it's an opinion segment, for example, surveys that are just not the best. So here's my survey question. Imagine 1,000 Idaho residents are going to be asked this. Are you in favor of a sugar tax? They probably should have stopped there, but then they go to say, knowing that sugar is harmful while consumed in excess and obesity rates in Idaho are higher than ever. What is your opinion? How do folks feel about that? Does that sound like we're going to get sound data from that statement? Any volunteers for what might be the problem with running that question and collecting the observations? Yeah, go ahead.
The sugar in fat, so it has to be balanced with sugar.
Right, it's almost shaming me and saying, no, I'm not in favor of the sugar tax, despite all these terrible things you just told me. It's shaming people in one direction, right? So that's the problem with these kinds of questions. If you run a survey question, usually a lot of people are going to look at those questions. They're going to dissect it, tear it apart, and look for any hint of bias. It's not always going to be this in our face that we have a problem. Sometimes it's really subtle that there is a slight skew in the answers they're expecting. If you can spot that, you'll know there's going to be a massive problem with our survey. It might run on the news, appear in USA Today or something like that. But the more it's dissected, it could never be trusted. So here, the problem is the responses will be skewed into saying yes. Well, why is that a big problem? If the survey question is really just trying to figure out where does Idaho stand on the sugar tax, they should have just deleted this part. We won't know what people really feel like. We'll only know how are they going to respond after they're shamed or coerced into one answer or another. So here we can say this survey will not give meaningful data on Idahoans' opinions on a sugar tax. So that's what response bias could look like. It can come in very different ways, shapes, or forms, but it's always good to be aware of them when they happen. Any questions at all, folks, with these quick examples so far? Okay, well, we're pretty much at the end of the notes. I just have one more example I want to discuss. And again, one thing we mentioned before, if it just says example, it's unnumbered, really all we're trying to do here is illustrate what the definition is trying to say with a particular setting or example. It may not be a direct question I'm asking WebAssign, but more just things we should be aware of. So last thing it says, non-response bias. For me, telephones are probably a great way to think about non-response bias. What might happen here is you may have a sampling frame, for example, right here. Now you have to collect data by contacting, say, these 7 individuals in yellow. Now, here's where sampling gets really tricky and why studies are so expensive. The how and how they contact you, these students, is very important. If they're just going to give you a phone call, well, you might not ever see it, especially if they're calling, say, a landline number or something like that. They're potentially going to have to track these students down and interview them and get some information. How they do that, again, could be very costly, and some people may not want to be part of a survey, even though they were selected. So in all those cases, we're dealing with non-response bias. We have a sample, but if many people in that sample are not responding, everything about that study could be in jeopardy by chance. So here's a really fast example in this case, along these lines. Suppose again, our population is all Idaho residents. We're going to select 1,000 residents and do the following. And here's where this study would go really, really tremendously wrong again. For each resident in the sample, of which there's 1,000, call their phone number and ask if they will participate in a 25-minute survey. If you got that call right now, say you're not in class, would you do it?
No.
I agree. The non-response would probably be in the 90% or higher. Probably only bored people or people who are just giving nonsensical answers for the fun of it are going to be the only people who engage with you. So this study, it might seem great. The company or corporation that designed it might have fought you on the 25 minutes saying, well, we got to know all these things about them. But at the end of the day, this is all wasted energy, right? Doing these studies and getting real and meaningful data is hard and extremely expensive. So here, the problem is most people will not engage in the survey. And so the data becomes biased through the non-response bias indicated here. So again, that is a massive problem for us. And even if some people did respond, maybe you have 100 responses, those responses cannot be trusted. Even if you think they weren't yanking your chain, they were real and earnest responses, because there might be a difference of why people engaged with you and the people who completely shunned you and never picked up the call or just hung up on you. If we can't find out what those differences are, then our study is, again, completely flawed. And once you have bad data and statistics, there's no fixing it once there's bias. You have to just restart the study, maybe do a better sampling method, and start over from scratch. That could be a waste of potentially tens of thousands of dollars, depending on how big your sample size was targeted at. Well, that's the conclusion of section 1.3 notes. Any questions or comments that folks would like to discuss before we turn the page on this? Okay, well, believe it or not, we're nearly done with chapter 1 already. It's kind of a fast chapter, mostly just vocabulary that we're getting used to. A lot of these vocabularies I'm putting on the notes are things we'll see here and there all over the textbook. Let me return to the Moodle website just for a moment. So section 1.2 was observation and experimentation, just knowing the meaning between them. 1.3 is planning an observational study, and now we're going to explore planning an experiment. Now, experimental design is a big subject. ISU has an entire course on designing experiments, a 400-level course for 3 credits. And because we're just in an intro class, this is a really fast introduction just on experimental design. So if you've seen these kind of topics before, you might think, well, I didn't talk a whole lot about certain things like factors or multiple treatments and so on. We're just going to look at the very surface topics here, which is fair. It's just an introductory course. Then section 1.5, that's kind of a summary and review of everything in chapter 1. Whether you made an experiment or an observational study, we also want to know what kind of conclusions can you even make. Things like cause and effect will come into this section here as well. We'll jump into section 1.4 and see what we're getting into. So like we mentioned before in the prior sections, experimental design is very special for us in statistics and as a society as a whole, because if you constructed a sound experiment, took a look at your conclusions, you can establish cause and effect potentially, depending on your experimental results. And oftentimes, that is the key things people want from statistics. Well, let's take a look at just some of the initial definitions here. We're going to be doing something called a simple comparative experiment. We don't necessarily use that word a lot. There are other kinds of experiments, but if you're curious what we're talking about just on these notes, that's the type of study we're running. We're going to have something called a response variable. We measure that under different experimental conditions, and those are, say, the treatments. Next, we have the idea of a so-called experimental unit. Our author says it's the smallest unit to which a treatment is applied. That's a tricky definition on its own. Say, for example, maybe you're in biology and you're doing an experiment on laboratory rats. The experimental unit wouldn't actually be just the rat. You might have your rats laid out in cages, and everything about that rat is the experimental unit. It's going to be the cage, the little things that hang on it, the water bottles, the actual, what do you call that, the cedar clippings down below. Everything about that rat is part of the experimental unit, because all of those things can influence what might happen to that rat. Maybe we're testing drugs, blood pressure drugs, and if there's something off about those cages, maybe the problem in the cage is altering the blood pressure, not just the drug. So everything that happens to our subject or unit is considered the experimental unit in a study. Well, any questions so far, folks, getting through those definitions? Okay, And probably the most important thing about a designed and controlled experiment is the randomization. Let me give you a worst case scenario. Suppose we have 20 people. We're going to run an experiment where maybe a person jogs for 5 minutes with a weighted backpack, and maybe the other person jogs for 5 minutes with, how about, weighted ankle weights? Don't do that, it's dangerous. If we ran that kind of study, suppose we just told people, well, sign up on a sheet which way you'd like to go, with the backpack or the ankle weights. It's all up to your preferences. Then you ran the study, took your measurements, made your conclusions. The big problem there was there is no randomization. People were allowed to choose what treatment they would like to go into. And there could be certain reasons why people choose one thing or another, and we can't track that anymore. We now have massive bias, and we lost randomization. So a good experimental design must have some kind of randomization, or else your conclusions are essentially useless, unfortunately. Well, for our experiment, we're going to do an example one. This one is really just kind of silly, but it's relatable. It's a great way to go through the definitions. So we're going to use this setting as we study all of our terminologies above. So here's how it goes. It says a pizza delivery driver, always trying to increase tips, runs an experiment on his next 40 deliveries. So this is what the person's going to do. He flips a coin to decide whether to call a customer from his mobile phone when he's 5 minutes away, hoping this slight bump in customer service will lead to a slight bump in tips. So that's the reason he's going to do this. Next, it says, after the 40 deliveries, he'll compare the average tip percentage, let's highlight that as well, between the customers he called and those he did not. So let's see if this qualifies as an experiment. The experimenter, let's consider him to be the actual delivery driver. Did the experimenter actually assign people to different treatments? Some say yay. I agree. This looks like a real actual experimental design. Anyone volunteers for what the first treatment should be? So we have 40 deliveries that are going to be made, and he's doing different things to each one of those deliveries. Any volunteers for what one treatment could be? Yeah, go ahead. Excellent. Exactly what the first treatment ought to be is right here. He flips a coin to decide whether to call a customer from his mobile phone when he is 5 minutes away. And it says somewhere down the line, he's also going to have customers that he did not call. So it looks like those are going to be the treatments. It's one of those things where we have to really read and reread the problem. Unfortunately, that's again par for the course of statistics, but we get better at it with time for sure. So let me put here, treatment one, call 5 minutes before delivery. The driver is hoping that call, I mean, it's nice to know the delivery driver's about to show up. I kind of like that feature on DoorDash, looking at the little tracker and things like that. So I might be inclined to tip higher if I get that kind of convenience. And treatment two is do not call. You might wonder, why do we even need treatment two? But that's going to be our baseline. We're going to see what the average tips are in treatment two, the average tip percentage in treatment one, and hope that treatment one is higher, maybe substantially higher. And that's going to be enough evidence potentially for the driver to start maybe calling all the time. Hopefully they're drive safe while they do that. So those are going to be the experimental conditions. Our author mentions that's synonymous with treatments. So either way you'd like to say it. Any questions so far, folks, with part A? Okay, let me scroll just a little bit next. Oh no, I want the response variable here. So now we need to describe what is the response. Well, he's going to run this experiment with 40 different experimental units. And each time what he does is, let's see here, he's going to take a look at the percentage tip on every driver. It turns out that's the response. So we can say here, the response variable will be the average. Oh, sorry, that would be for an entire group. Let's just say the tip percentage. He'll have 40 such numbers and is going to average them inside treatment 1 and inside treatment 2 to compare between. So far, so good. Now, let's take a look at one other thing here. For this to really be an experimental design, recall it should have random assignment somewhere. Doesn't look like that's part of the questions down below, but before we move on, we should know, is it really an experimental design? Anyone see where the randomization would be in this problem? Exactly, the coin right here is where randomization is manifested. He's not going to choose on his own necessarily who he calls first. If he did do that, that would be a problem. Say, for example, he's doing 40 deliveries, right? He calls the first 20 and then doesn't call the last 20. Well, he's probably going to get a pretty good average on the first 20 deliveries he calls because he's fresh on his shift. He's not weary. He's probably going to be really great on his customer service. And that's going to be a massive problem. But if we randomize who he calls and who he doesn't call, those differences get spread out and we have less biases. Is it a truly random? What if he flipped the coin and got, say, like 20 heads in a row? That's a really small chance, right? But then we can assume the rest of the actual deliveries would have to be the other outcome of the coin flip. So this would really do the job. We have randomization, we have multiple treatments, we have a response that we're considering. Last thing, and probably the trickier thing, is the experimental unit. Kind of like we were saying with the rat earlier, an experimental unit is not just the pizza. It's not just the person who gets the pizza. It's something larger. Like for rats, it was the entire cage, the enclosure, potentially the room that it's in could be part of it. How about this situation? Anyone see what the experimental unit should be for this situation? Close. It's going to be part of it, but there's even more that could affect the tip that you get from the actual pizza that's delivered. So, any other volunteers? You're on the right track, but there should be something larger. Yeah. So you said the house, the delivery, and the restaurant we ordered from. Did I hear that right? Yeah, pretty much that's exactly what it is. It's going to be everything about that delivery. It's going to be the moment that the customer decides, I'm going to order a pizza, it starts to enact that. They might go through an app, they might call on a phone, they might walk into the shop, which would be weird for deliveries, maybe not walking to the shop. But everything that happens in that process will affect the tip percentage. If they're calling the restaurant and the person that picks up is rude, the tip might be 0 and the delivery driver might think, what the heck? I even gave him that 5-minute heads up, but I got nothing. Wasn't his fault. It was something else that happened to that experimental unit. So for the sake of brevity, let's say it this way. Like you're saying it's everything. The experimental unit is the entire pizza delivery process from ordering to delivery. Once that pizza and the tip, if the person got one, has changed hands, that's when the entire experimental unit would end. Does that make sense to folks on identifying this right here? Okay, these are pretty tricky. And I did want to mention that at WebAssign, some of these are, I'd say, extra tricky as multiple choice questions. Take a look at their responses that they give you for the multiple choices. And usually in this section, it's just one little word off that makes or breaks the entire response. If this was a quiz problem, I'm grading this in a much more forgiving way because experimental design is tricky. I'm not going to make this a big part of the course. But let's now go off to the next portion, unless there's any questions or comments. Okay, this is considered a complete comparative experimental design, but if we want to get even better data, there are much more things we have to take a look at. We're just scratching the surface on these notes, but here's the next issue that can come up. The so-called lurking variables. When we think about lurking variables, we're thinking about what could go wrong in this same pizza delivery that we described here. Example 2 is the same setting. It's just a question down below that has changed. So it says here, additional variables that can cloud a study are called lurking variables, clouding the study by affecting the response variable in ways that we don't really care about. Like say, the customer called the restaurant and got chewed out by the staff. It's not something I'm worried about. We're worried about is calling 5 minutes before going to increase the tip. So anyone see any variables that could be problematic, that could influence the tip percentage, but the driver probably doesn't really care about? I'll go first. How about day of the week? Now, this driver is probably not necessarily doing all 40 deliveries on one shift. That doesn't sound reasonable. That sounds like a lot of work. But the actual day that these deliveries happen is going to be important, you could imagine. Say, for an example, he does some deliveries on a Saturday. Well, if that Saturday is busy, if there's a football game going on or something like that, the actual pizza restaurant might be slammed, service might be delayed, might be poor service. When he opens up the pizza, it might be incorrect. That could be a massive problem. That actual day of the week could influence the tip percentage. If it's a Monday and there's not too much action at that pizza parlor, your pizza is probably going to come really fast and look perfect. You might tip a little bit more because of that. So that's one lurking variable that we should already have to track on. And this problem, it says, name at least 3 variables. If this was an exam question, I usually give you an idea of how much response is needed by saying something like this. That way you're not spending too much time on one question. But how about another potential lurking variable? Yeah, go ahead. That will go up here.
Damage roads, so any pathways to the house.
Gotcha. Yes, damage on roads. Forgot to spell roads, one moment. Roads to the house. And I think I can almost visualize what you're saying. If there's massive potholes to get to that one house, well, when they open the pizza to show you, it's probably going to be stuck to the top of the cardboard, and you're probably going to get a 0 tip on that. You might be told to send it back or something like that. So again, this had nothing to do with customer service. It was just a lurking variable that we should be aware of in the experiment. And in a more sophisticated experiment, they would track all this stuff. For every experimental unit, there's probably going to be dozens of variables that they're taking a look at. Distance to the delivery, time of the day, the damage on the roads, all that kind of stuff is going to be meticulously tracked. So when that tip occurs or doesn't occur, we can see how the lurking variables are influencing all that and know it might not just be about calling 5 minutes before or not. Well, we need one more. Any volunteers for the third potential lurking variable that could be a problem? Yes, go ahead.
Heavy traffic or accidents.
Oh, absolutely. Traffic accidents en route. So if this was your response to, say, a quiz question, maybe, I'd say that's terrific. These are 3 different lurking variables that we have to watch out for running this experiment. And folks might have thought of many more. So for example, the accuracy of the order would probably be a big one. If it's, say, just completely wrong, you're not getting a great tip. I'm thinking of lurking variables that are making things go wrong, but their lurking variables could make things go right, make people tip more, but it's stuff that they don't want to account for. Maybe the order is wrong and you sent them 2 pizzas when it should have been 1. person feels guilty and just throws in another $10. Well, that's accuracy of order, for example, that needs to be tracked or else the conclusion of the experiment would be flawed. Well, any questions, folks, about dealing with the lurking variables in these settings? Okay, fun stuff, all about delivering pizzas. You can imagine this could happen to you or someone you know in your life, considering these kinds of issues. But really, the whole purpose of this silly example is to dissect the technical definitions and imagine ourselves and actually in that role dealing with these issues. Well, let's keep on scrolling. We're, I'd say, about halfway done with these notes. So that means we'll probably finish them on Thursday's class. Let's maybe scroll to about here. We'll hide the placebo for the moment. So experiments also need to have a control group. That's our consideration inside of it. So the purpose of the experiment is to determine whether some treatment has an effect, as our author says. In that case, we need a baseline of some kind. If I want to say do an experiment where I called or delivered 40 deliveries, in the past, some experiments have been massively flawed. This is many years ago, before experimental design started to become more rigorous. But sometimes people, if they ran experiments in the past, they would call 5 minutes before for every of the single delivery, get their data and say, looks like calling is helpful. But actually, that's a meaningless way to go unless you had something to compare against. We need to know how the tips increased or decreased compared to doing nothing at all, the control group itself. So our control group gives us a baseline to compare what the other treatment is doing. The control group can be a treatment inside the actual experiment itself, like in our situation. So back to example 3, pizza delivery driver is going to deliver 40 pizzas. 20 of them, he'll call 5 minutes before, hoping to get a higher tip, and 20 of them he won't call. What would you say the control group ought to then be in this situation? Exactly. And in our top responses here, treatment 2, that is the control group. So not calling is our baseline. We want to see what tips does he get normally when he doesn't do anything different. Then on the other half of the experimental units, the other 20 deliveries, that's the other treatment that we're going to compare the control against. So we can say here, the control is the treatment of not calling. And you can imagine how this could go really, really wrong. Sometimes people have done things like, say, ran an experiment on weird supplements, like maybe St. John's wort or something random. A strong claim might be that St. John's wort helps with anxiety, but unless there is a control, and a specific kind of control we'll call placebo, to compare against, that study is meaningless. Those kinds of things have to essentially beat a placebo to be considered effective, and oftentimes that's a very hard thing to show. So let's take a look at what we mean by placebo. So it says here, to determine if a treatment really has an effect, comparing a treatment group to a control group is not always really going to do the job for us. You can imagine there's a lot of things that might go awry. And the major issue here is anytime you do an experiment, the designer of the experiment, the people a part of the experiment, are injecting their own expectations onto the data, whether they're trying to or not, or no matter how hard they're trying to prevent it. Imagine again, you're the pizza delivery driver. You're delivering a pizza and you know this is one that you did call 5 minutes before. Now, as you walk up to that door, you're probably going to look more friendly and not even know it. Your tip is going to go up because your expectations are you did a good job by calling them. You probably are going to get a higher tip. But if you had no idea whether the call was made or not, you're just going to be yourself. And that's going to allow the data to be less tainted with your expectations entering inside them. So placebo is a treatment that's identical in appearance, smell, taste, if that's part of what's going on in the study, received by the treatment group, except that it contains no active ingredients. Doesn't really have to be about ingredients, but that's what's happening in this simple example down below here. So this allows researchers to determine the treatment has any effect over and above the control, which will be considered with the placebo effect as well. So placebos are weird. It's all about your expectations. Now let's consider this study as we think about the placebo effect here. So we're going to have 20 student participants. That could be practically us. I think we're 19 people altogether. And we're going to randomly assign them to the 2 treatment groups as indicated. So the treatment 1 will be to drink 1 cup of coffee. Treatment 2 will be to drink 1 cup of decaffeinated coffee. Then after 10 minutes, here's where it gets exciting. Everyone is going to solve a 100-question math quiz and will be told to solve as many as possible in 15 minutes. So that's just intentionally nerve-wracking, right? No one's going to solve all 100. We're just going to see how well you perform and compare the 2 different treatments. The response will be the number of correctly solved questions. Now the question says, which treatment is the placebo? Anyone see which one it might be based off what we see? Exactly, the decaffeinated. That's provided we just didn't tell anyone that some of the coffee is decaffeinated. If you do a psychology experiment, sometimes that's what's going to happen. You might not know that there are multiple treatments because they don't want to tell you. They don't want your expectations entering into the actual experiment itself. If you did the study and they tell you, well, I'm giving you decaf, and you hear someone else is getting caffeinated coffee, you might feel, well, my performance might not be as good. And those feelings alone will affect your actual response, the correct questions on the actual 100-question quiz. So it's best that nobody knows what's going on. So none of the subjects will know if they got the active coffee or the placebo treatment, the deactivated. So we'll say here, the placebo is in treatment 2. And I kind of talked too much. I was going to ask the class about this, but let's ask it one last time. Would you agree that treatment, having a placebo, is very valuable in this experiment for getting unbiased data? Any volunteers for just a quick way to answer this question here?
Could be more for comparison.
Exactly. If we're going to compare this having caffeine and this having no caffeine and accuracy, then it's valuable to have a placebo, so no one's expectations are going to mess with those numbers on either treatment. So here we can say, since students have expectations about the effects of coffee, our data will be biased without a placebo. So having a placebo is really very helpful. And the way to make the placebo effective is we need blinding. We need to have all these 20 students completely unaware which treatment is which. They shouldn't even know that there is a treatment or multiple treatments. They should think everyone's getting the same. And it gets even deeper than that. The experimenter themselves, the person who's going to record the actual data here, that person shouldn't know who got what treatment either. Because even though it's responses on a math test, as you're reading those responses, you can imagine, well, the student had caffeine, and I'm not sure how they answered problem 15. I'm not sure if that's a true or a false, but they had the caffeine. It's probably right. I'm going to mark that as correct here. It looks like a true. We're getting biased ourselves if we know which treatment was actually applied. So we'll talk about when we come back on Thursday, blinding, double blinding, and all those related matters. Well, any questions at all, folks? Okay, sorry, went right to the minute here. It's kind of fun stuff talking about the things, the ways experiments can go wrong. If you have any questions, I'll be happy to help, but this is one of those days where I have a 10-minute turnaround to the next class. Sorry about that. It's a little bit awkward. Well, I'll see you all on Thursday and have a great night.